Hello everyone, welcome back to our channel. Today we are going to discuss about what is the relative motion. What is the relative motion? Motion of one body with respect to another body is called the relative motion. Where we are observing really, look here, this is car A and this is car B. Otherwise any observer, your friend, we can take it. Another friend is C. If this car is moving away from this and same car is moving approaching your friend B. So with respect to C, this car is having the slow motion. With respect to B, he feels that fast moving car, it is coming towards me, like that he feels. This type of observations all belongs to relative motion. Here I have written that XAB. What is XAB? Displacement of A with respect to B, we are writing XA minus XB. Like that, if we are writing XBA, that is the displacement of B with respect to A, we are writing that expression. But both are having the same magnitude. Then how to write the relative velocity and relative acceleration? Suppose a man is running in rain. Velocity of the man. They didn't mention anything with respect to observer, with respect to tree, or with respect to rain and all this. At that time we can consider the man is moving with respect to ground. Like that, how to write the relative velocity? Look here. We are writing XAB equals to XA minus XB. Then we are doing the differentiation with respect to time. XAB equals to differentiation of rate of change of displacement of first body minus rate of change of displacement of second body with respect to time. This is the relative velocity of A with respect to B. It should be right, velocity of A, they didn't mention anything, means it is with respect to ground, minus this is the relative velocity of the B. So like that we can take this is the velocity of A with respect to B. These we can apply for equations of motions also. Look, what is the first one? V equals to U plus AT. Relative final velocity equals to initial relative velocity plus relative acceleration into time. For that second one, S relative equals to U relative into T plus half into A relative into T square. Then final velocity square minus initial velocity square, we can write like this. 2 into A relative into displacement, this one. So these are the belongs to relative motion. Then few more applications we are discussing. Suppose this is the velocity of car A and this is the velocity of car B. What we are observing, both are moving the same direction. So angle is how much? Theta equals to 0 degrees. In this case, we should write it VAB equals to VA minus VB. Example, if VA equals to 100 meters per second and VB equals to 50 meters per second. How to find out the relative velocity in this case? VAB equals to, direct we can take it, 100 minus 50 is the 50 meters per second. And one more example, see, this is car A, it is moving with how much velocity? VA, and another car is moving opposite to this one. Here both are approach each other, theta equals to 180 degrees. So here relative velocity is VA plus VB. VA plus VB. Suppose two trains are there. VA is like 40 kmph and VB is 30 kmph. In this case, what is the relative velocity of the trains? Velocity of train A with respect to B is 70 kmph. Suppose we want to find out the relative velocity of B with respect to A, means minus 70. That sign is changing here. So approach means we are taking plus and both are moving same direction, means we can take the minus. Two examples relative velocity we are discussing here. Our first problem is one bird is there, two cars are there. First car is moving with how much velocity? V1. Second car is moving with V2 velocity. both are moving towards each other. So angle is theta equals to 180 degrees. So in this case, what is the relative velocity? We can write it v12 equals to v1 plus v2. In our problem only, they have given the distance between these two cars is d. But here one bird is there. This bird is flying to and fro. Once it is coming, then it is going like that till both the cars are coming towards each other and meted. That bird is having the to and fro motion. The question is, how much distance covered by the bird? So in this, first we can take it time. Time general formula is distance by velocity. We are taking here distance is d, relative velocity v12. So t equals to d by v1 plus v2. But bird also taking the same time, no? So here bird time and the how much time these two cars are approach each other also same time. So based on this we can, but clearly in our problem v3 is the velocity of the bird. This is the velocity of the bird. The question is how much distance covered by the bird. So distance already we should consider distance covered by the bird equals to velocity, relative velocity into time. Relative velocity into time. But here bird velocity clearly they have given that is the v3. This is belongs to bird means v3 into t. But instead of t we are taking d by velocity of first car plus velocity of second car into v3. This is the distance covered by the bird between two cars. That too it is having the to and fro motion. We do one problem based on this. Look here. If velocity of bird is 2 meters per second, velocity of first car is 100 meters per second. Like that velocity of second car is 50 meters per second. In this case, how to find out the time and how to find out the distance covered by the body? First of all, for finding the time, d equals to, we can take it 50 meters. Distance by velocity. Otherwise, distance covered by the bird, we can take it directly this formula. 50 by v1 plus v2 is the 150. And instead of v3 we are taking 2. So answer is 2 by 3 meters. Like that we can calculate. This is pure. Next question is related to relative motion only. Mostly we can observe in our daily life in the case of shopping malls. There are escalators are there. The question is, the person he walks on the stationary escalator, he took t1 seconds. When the escalator is moving, the person is stationary condition, he took t2 seconds. Then in third case, we should find out how much time he will take when he walks. As usual, the escalator is going up. So the given data is t1 seconds when he walks on the stationary escalator and t2 seconds when the escalator is going up. Then how much time we should find out he is walking at the same time that escalator is moving. For this we can take it velocity of man with respect to escalator, we are writing Vm minus Va. But we should find out the velocity of the man means we can take it Vme plus velocity of the escalator. So this is the first condition. Velocity of the man, what we are taking, distance by time. We should find out this one. We can take it, that is the t3. Then velocity of the man with respect to escalator means first case, that escalator is in stationary and he walks up means same distance he covers L by t1 plus in third case he is at rest condition or he is at stationary, that escalator is moving up. So same distance L. This is moving with respect to ground. That's why we are not mentioning that frame of reference. This is the T2. In all cases, L is cancelled. 1 by T3 equals to 1 by T1 plus 1 by T2. After simplification, he is taking how much time? After taking LCM and the cross multiplication, T1 plus T2. We do one problem based on this. See, he walks up in stationary escalator is, the time is T1 equals to 2 seconds. Otherwise this is 4 seconds. Only escalator is moving, we can take it T2 equals to 2 seconds. Now the question is, he is walking and the escalator is also moving. How much time it will take, he will take to cover the distances? Direct we can use this formula, T3 equals to T1 T2 by T1 plus T2. So 8/4 into 2 by 6. Our answer is 4/3 seconds. Next question is related to relative motion only, but here we are taking polygon. Polygon means many sides are there. Suppose we should consider the n sides and the particles are at the another 2 sides are there. So the person is moving towards the next person, like second person is moving towards the another person. How much time they will take to meet each other means the direct formula is initial separation by 2v sine square pi by n. Suppose we are taking one triangle. Triangle means how many sides are there? 3 sides we are taking. A, and the persons are at the sides of the triangle. When he is moving towards the A to B, then he is moving from B to C, like that. When they will meet each other means we can use direct formula. Initial separation is how much here? A by velocity of that person is 2 sine square, 2v sine square. Here pi is 180 degrees. How many sides? 3 sides. This is 60 degrees. Then A by 2v sine square 60 means 3 by 4. After simplification, T equals to 2A by 3v. One example we are doing. Here A equals to 4 centimeters and V equals to 2 meters per second. How much time it will take? Both they will meet each other means you can take it 2 into 4 centimeters. Otherwise we are taking 4 meters by 3 into velocity is the 2. So after simplifications 4 by 3 seconds. Suppose we are taking square. How many sides it is having? It is having the 4 sides. A. Here the person is moving towards this person. Like that when they will meet means we can use this formula. T equals to A by 2V. What is the difference here? Same, instead of pi we are taking 180 degrees, but the sides are we are taking 45 degrees. So T equals to A by 2V into sine 45 is 1 by root 2 whole square means 1 by 2. We are getting A by V. One example also we are taking. Here A equals to 6 meters, V equals to 2 meters per second. In this case, how much time it will take? T equals to A by V, 3 seconds. Like that when we can go for pentagon also 5 sides are there. Instead of n we are taking 5. Instead of n we are taking 5. Suppose it is hexagon means we can take the 6 like that. Like that we can deal that relative motion problems. Motion of one body with respect to another body is called the relative motion. Especially in the case of 2 trains, 2 cars, we can take the relative motion to each other. Each one we have to follow that if 2 bodies are same direction, theta is 0 degrees. If 2 bodies are opposite direction means theta is 180 degrees. So we can do the simplification. Thank you everyone. Please subscribe my channel.